started as a faint smudge, barely more than a whisper in the deep sky. A patch of light so dim, so subtle, that even the telescopes almost missed it. But what they found when they looked closer changed everything. Some discoveries roar into existence. Supernovas, gamma bursts, cataclysms. Others arrive in silence, like a secret finally choosing to speak. This one was the latter, a small, unassuming glow at the edge of time, a galaxy that should not exist. Astronomers stared at the data, ran it again and again. The redshift was wrong. The age didn't fit. The structure, impossible. Galaxies like this weren't supposed to form so early after the Big Bang. And yet, there it was, billions of light years away, older than it had any right to be. This new galaxy stared back at us like a ghost from before time began. And suddenly, the question that had guided astronomy for centuries began to unravel. Do we really understand the universe at all? There's a peculiar beauty in moments like this, when certainty collapses. The scientists, seasoned veterans of the cosmos, sat in silence as the first full image came through. The galaxy was compact, luminous, dense, filled with heavy elements that shouldn't have existed yet. The laws of cosmic evolution said it couldn't have formed. But the laws, it seemed, had other plans. Some called it the impossible galaxy. Others simply called it the blink, because that's what it felt like, as if the universe had blinked, skipping billions of years of expected growth and maturity in a single cosmic heartbeat. We thought we knew how the cosmos evolved: gas into stars, stars into clusters, clusters into galaxies, galaxies into cosmic webs. But this was a galaxy that seemed to appear fully formed when the universe was still a child. How could something so vast, so structured, exist when the cosmos was barely 300 million years old? A fraction of its current age. It shouldn't. And yet, it did. When astronomers talk about the early universe, they're usually speaking in the language of simplicity: hydrogen, helium, and darkness. The cosmic dawn was supposed to be slow, a gentle ignition of starlight spreading across the void. But the new James Webb Space Telescope changed that picture forever. For the first time, we could see far enough, deep enough, clear enough to witness the beginning of galaxies themselves. And what we saw didn't fit the script. This new galaxy, along with a handful of others, appeared where there should have been emptiness. It was massive, not a few thousand stars, but billions. Its light was red-shifted to a point that placed it just a few 100 million years after the Big Bang, when such complexity shouldn't have existed. The instruments checked out. The data was sound. The shock undeniable. It wasn't just another galaxy. It was a challenge to the very timeline of creation. One of the astronomers described the feeling perfectly. It's like finding a skyscraper in the middle of a desert, before the first brick was ever laid. The discovery sent ripples through the scientific community. Theories of cosmic inflation, dark matter evolution, and early star formation were suddenly under scrutiny. If galaxies could form faster than we thought, if heavy elements could exist so soon, what else were we wrong about? The universe, it seemed, was rewriting its own story. And yet, there was awe in that uncertainty. Because in science, shock isn't failure, it's revelation. It means we're standing at the edge of knowledge, where the known gives way to the vast, exhilarating unknown. So let's take a breath and go back, far back. Imagine the universe just after its birth. A sea of radiation, cooling, expanding, slowly giving rise to the first atoms. No stars, no galaxies, just darkness and potential. Now imagine, out of that darkness, gravity begins to whisper. Tiny ripples of density, the seeds of structure, start to form. In time, these will become galaxies, clusters, superclusters. But according to our models, that process takes hundreds of millions of years. This new galaxy formed in a fraction of that. It's as if the universe hit fast forward, jumping ahead to a stage of complexity that shouldn't have been possible yet. Some scientists began to wonder, are our measurements wrong? Are we misreading the light? Could there be something about dark matter or the nature of time itself that we've misunderstood? Or could the universe have more than one beginning? The discovery has ignited new debates, new questions, new missions. If one galaxy like this exists, there must be more. What if the early universe wasn't as uniform as we thought? What if some regions evolved faster, like pockets of accelerated creation? Maybe this galaxy isn't an exception. Maybe it's a clue, a glimpse into a deeper cosmic truth, that the universe doesn't follow a single rhythm, but many. That creation itself is not linear, but symphonic. And if that's true, then the very laws we've trusted, the ones that shaped our understanding of space, time, and matter, may only be one verse in a much grander song. So tonight, as we gaze into the black, distant ocean of stars, remember this: the universe is not finished surprising us. For every equation that seems certain, there's a galaxy waiting to challenge it. For every map we draw of the cosmos, there's an edge we haven't yet reached. And sometimes, all it takes to rewrite everything we know is a faint smudge of light in the dark. Because that's how truth begins, quietly. Then, suddenly, it changes everything. Every discovery in astronomy begins with light. It's our oldest messenger, the one thing that travels across billions of years, carrying with it the story of everything that has ever existed. But this light, the one coming from that impossible new galaxy, told a story that defied the very language of cosmology. When astronomers split the light into its spectrum, expecting the familiar fingerprints of hydrogen and helium, they found something unexpected. Traces of heavier elements, carbon, oxygen, even magnesium. That shouldn't have been possible. The early universe was supposed to be too young, too raw, too untouched for such complexity. It was like finding gold in a world that had never known stars. Light is time. Every photon that strikes our instruments began its journey before Earth even existed. When we look deep enough, we're not seeing distance. We're seeing history. And that's what made this galaxy so shocking. Its light had traveled for over 13 billion years, from an era so ancient that the first galaxies were just starting to flicker to life. But this one, it was already bright, structured, and mature. If it was truly that old, then either our models of cosmic evolution were wrong, or time itself was not as linear as we thought. For decades, we've believed that the first galaxies were small and chaotic, little islands of starlight clumped together by gravity. Over billions of years, they merged, collided, and grew into the grand spirals and ellipticals we see today. But this galaxy shattered that idea. It was already massive when the universe was barely out of its infancy. 1 billion stars shining when there should have been only a few thousand. Some astronomers whispered an unsettling question. Did we misunderstand the birth of time? Because if galaxies could form this fast, maybe the early universe wasn't as calm and uniform as we thought. Maybe something, or someone, accelerated it. The James Webb Space Telescope has eyes unlike any other, tuned not to visible light, but to the infrared, the ancient glow stretched by the expansion of space itself. Through Webb, we see the universe as it was, when light was young, and in that deep red glow, this galaxy stood out, compact, intense, burning with a brightness that no early system should have. It didn't flicker like a newborn. It blazed like an adult star city. The paradox wasn't just in its age, it was in its nature. How could it be so evolved when the cosmos itself was still learning to exist? As data poured in, theories began to multiply. One group proposed that dark matter, the invisible scaffolding of the cosmos, might have clumped faster than expected, creating early pockets where gravity became extreme enough to forge stars in record time. Another suggested that our understanding of the speed of cosmic expansion might be flawed, that the cosmic clock we've been using could be slightly off. And then, there were the radicals, those who whispered that maybe this wasn't our universe at all. Maybe what we were seeing was light from a parallel region of space-time, a reflection bleeding through the boundary of another reality. It sounded absurd. But so, once, did the idea of galaxies themselves. For the astronomers, it wasn't fear that dominated the room. It was awe. Because this wasn't the failure of science, it was the birth of a bigger one. Every time light surprises us, the universe grows larger. Every time a photon tells a story we can't explain, it reminds us that our understanding is still in its infancy. As one physicist put it, we think of light as something that reveals, but sometimes it hides. Maybe this galaxy wasn't showing us something new. Maybe it was reminding us of something we've forgotten, that the universe is not obliged to make sense. Imagine the scene. Late night at the observatory. The data streaming in, silent except for the faint hum of cooling fans. A cluster of scientists, coffee cups half empty, eyes red from staring at screens, watching the universe rewrite itself line by line. And there, in the middle of it all, one faint blot of light, 12 billion years away, pulsing softly in digital color. That's how history happens. Not in explosions, but in realization. Light older than our species, crossing the void to tell us that the story we thought we knew was only the preface. The paradox of light isn't that it shows us the past. It's that it forces us to rethink the future. Because maybe, just maybe, time, creation, and consciousness aren't what we thought. And this galaxy, glowing against the edge of forever, might just be the first proof of that. Every mystery needs builders, the minds that refuse to look away when logic falters. When the new galaxy was confirmed, the world's greatest astrophysicists gathered, not to celebrate, but to question everything they thought they knew. Imagine that moment. Data spread across glowing monitors, formulas scribbled on whiteboards, voices clashing and harmonizing in the pursuit of truth. They were not just scientists now. They were archaeologists of time, standing at the edge of the beginning. No one could deny it. The galaxy existed. It was there. But what could have built it? The architects. That's what some journalists began calling these astronomers. Not because they created the galaxy, but because they were trying to rebuild the universe around it. Every simulation, every model of cosmic formation had to be redrawn. If the Big Bang had given rise to matter roughly 13.8 billion years ago, and galaxies took hundreds of millions of years to form, then how could this one, compact, massive, fully structured, appear only a few 100 million years after the beginning? It would be like walking into a forest minutes after planting the seeds and finding towering trees, complete ecosystems, and ancient roots already in place. Something wasn't adding up. Some scientists suggested that we had underestimated the power of dark matter, that it might have clumped together faster, pulling visible matter into place with invisible hands. Others argued that star formation might have been far more efficient in the early universe, producing massive stellar systems in record time. But there was another, stranger theory, one that spread quietly through the late-night halls of observatories. What if gravity itself wasn't constant? What if, in the earliest moments, the laws of physics we know today hadn't yet settled? That the universe was experimenting, testing, stabilizing. A young astrophysicist, barely 30, said it best during a late-night interview. "We always talk about the universe as if it knows its rules. But what if it didn't? Not at first." That question echoed through the scientific community like thunder. It's easy to forget that the cosmos didn't start with order. It started with chaos, and chaos, by its nature, doesn't follow instructions. So maybe, just maybe, this impossible galaxy was the product of a different kind of universe. One still learning to be what it is. A universe that, for a brief moment, bent its own rules. Meanwhile, telescopes all over the world, from Chile to Hawaii to the frozen peaks of Mauna Kea, pointed toward that faint patch of sky, measuring, verifying, questioning. The data was consistent. The redshift confirmed it. The galaxy's age, position, and brightness all pointed to the same unthinkable conclusion. It shouldn't exist, but it did. And in that realization, something beautiful happened. The scientific community, often fragmented by theory and ego, united. Physicists, cosmologists, mathematicians, philosophers, all spoke the same language again: wonder. Because when the impossible becomes real, there's no room for rivalry, only reverence. The media loved it, of course. Headlines screamed, "A galaxy that shouldn't exist. The universe's biggest mistake." Astronomers in shock. But inside the observatories, the tone was different. The scientists weren't shocked. They were alive. The universe had spoken again, and they were listening. For the first time in decades, the field of cosmology wasn't chasing the end of knowledge. It was standing at a new beginning. The architects began sketching new cosmic blueprints. Simulations ran on supercomputers for days, recreating the early universe in virtual form. They tweaked dark matter densities, altered the physics of star formation, changed the rate of expansion, yet no model could reproduce what the Webb telescope had seen. It was as if the universe had pulled a trick only it could perform. A paradox, hidden in plain sight. One researcher wrote in his notes, "We are staring at the footprint of a god, or a glitch." But maybe it wasn't either. Maybe it was something even grander, a reminder that the laws of physics are not limits, but living things, still evolving, still expanding alongside the universe itself. Every generation of scientists believes it's close to the truth, until the cosmos proves otherwise. And that's the beauty of it. Discovery doesn't destroy certainty. It refines it. The architects of the impossible didn't find answers that night. They found something better. Questions worthy of a new century. As dawn broke over the observatory domes, one astronomer looked up and whispered, half in awe, half in surrender, "Maybe the universe just wanted to remind us that it's still ahead of us." And above them, 13 billion years away, the galaxy shone faintly, a silent teacher, reminding us that creation itself is the greatest experiment of all. The impossible was only impossible until someone saw it. Now, it was real. And the architects were just beginning to build the new universe around it. There's a moment in every great discovery when wonder turns to doubt, when the excitement of revelation is replaced by a quiet, haunting question. What if we've misunderstood everything? That's where astronomy found itself after the discovery of the impossible galaxy. The data was real, the observations confirmed, the models shattered. For years, scientists had trusted their cosmic timeline, the steady expansion, the predictable evolution of light and matter. But now, something ancient and impossible had appeared. And every theory that once felt unshakable was trembling under its own weight. It wasn't just about a galaxy anymore. It was about the foundations of reality. At first, they tried to patch the problem. Maybe the galaxy just looks older than it is, some said. Maybe dust or distortion makes it appear more massive. Others argued the redshift could be misleading, that gravitational lensing might be tricking us, bending light from something closer, making it seem more distant. But as more telescopes confirmed the same readings, the truth became undeniable. This galaxy was that far away, and it was that old. It had formed at a time when, by every existing law, it should not have been able to. And so, a strange idea began to take shape. One that whispered through conferences and late-night research calls. Maybe the problem wasn't the galaxy. Maybe the problem was us. The way humans measure time in the universe is elegant, but fragile. We look at light stretched by expansion, the redshift, and translate that stretch into distance, then into age. But what if the relationship between expansion and time isn't as simple as we thought? A few bold physicists began to question the cosmological constant itself, the very number that defines how fast the universe expands. If it's not constant, then our cosmic clocks could be wrong. One physicist, Dr. Hannah al-Rashid, summed it up in a paper that went viral among the scientific community. We assume the universe behaves like a perfect metronome, but what if it's more like jazz? It was a poetic thought, and a terrifying one. Because if the tempo of time can change, if expansion and creation are not linear but fluid, then everything, from the age of stars to the fate of galaxies, must be reinterpreted. The universe might not be a clock. It might be a symphony. And we've only been hearing a few of its notes. Meanwhile, the James Webb Telescope continued to feed us more anomalies. More early galaxies that shouldn't exist. More evidence that the early universe was richer, brighter, and faster than any model could explain. It was as if the cosmos had reached a level of complexity before the rules of simplicity were even finished being written. The old models of formation, slow, methodical, structured, began to feel like bedtime stories for a child too young to grasp chaos. Now, chaos was real. The edge of understanding isn't a place, it's a feeling. It's that moment when your data makes sense, but your intuition screams that something fundamental is missing. That's where every astronomer found themselves, staring into the glow of an ancient galaxy, feeling the floor of knowledge shift beneath their feet. Maybe gravity works differently in the early universe. Maybe the physics we observe today are the outcome of evolution, not its origin. And maybe, just maybe, consciousness and observation are part of that evolution too. In a quiet lab late one night, an astrophysicist named Dr. Eliane Torres stared at a simulation running on her screen, an attempt to recreate the formation of the impossible galaxy using modified parameters. The code broke halfway through. The numbers diverged, collapsing into infinity. She smiled, tired and amazed. "Of course," she whispered. "The universe doesn't crash. We do." It wasn't defeat, it was enlightenment. The edge of understanding is where science becomes philosophy. When we reach that boundary, logic doesn't fail, it expands. It forces us to see that truth isn't static, that the universe isn't a puzzle to be solved, but a conversation to be continued. Perhaps this new galaxy is not an error in our equations. Perhaps it's the cosmos inviting us to evolve, to upgrade not our technology, but our imagination, because the greatest discoveries aren't found in answers. They're found in the courage to admit that the answers we have may no longer be enough. And as the scientists stared once more at that impossible light, 13 billion years old and yet brand new, they began to understand something profound. The universe doesn't exist for us to explain. It exists with us, to be rediscovered again and again. That's what the edge of understanding really is. Not a wall, a door. Every photon is a memory. Every beam of light that reaches us carries the record of something that once was. A cosmic diary written across space and time. And in that sense, the universe doesn't forget. It remembers everything. The new galaxy, that ancient, impossible bloom of starlight, wasn't just an object in space. It was a message from the past, encoded in light older than our planet, older than the concept of life itself. But here's the strange thing. The more we learned about it, the more it felt like the galaxy was remembering us. The deeper astronomers studied its spectrum, the stranger the readings became. Buried in that faint light were oscillations, subtle shifts that didn't match any known pattern of star formation or galactic motion. It was almost rhythmic, like the flicker of a heartbeat. One of the Webb engineers joked, "It's as if the galaxy is speaking." No one took it seriously, of course. But deep down, every scientist in the room knew that metaphorically, it wasn't far from the truth. Because what is data if not a conversation between the universe and those who dare to listen? As more galaxies like it were found, all impossibly old, impossibly complex, a pattern began to emerge. The light from these systems wasn't random. It carried correlations, similarities in frequency and energy that seemed too coordinated to be coincidence. Some suggested that this was the signature of an ancient cosmic event, a wave of rapid star formation triggered by something we still don't understand. Others whispered more daring ideas, that these galaxies were connected, perhaps by gravitational threads or quantum entanglement stretching across space-time itself. Could the early universe have had memory? A way to imprint structure faster than randomness could explain? What if the cosmos didn't just expand? It remembered how to expand. In theoretical circles, the idea of cosmic memory began to surface again. An old, fringe hypothesis, reborn in the light of Webb's data. The theory proposed that space itself retains information, not just through energy and matter, but through the geometry of its own fabric. That every curve of space-time, every fluctuation of quantum foam, carries echoes of what came before. If that's true, then maybe these impossible galaxies weren't anomalies at all. Maybe they were recurrences, patterns replaying themselves across epochs, as if the universe, like a great musician, keeps revisiting its favorite theme. The concept wasn't new. Ancient philosophers had dreamed of eternal cycles, of universes dying and rebirthing endlessly. Modern cosmology had long debated the same, whether the cosmos was a one-time explosion or a recurring breath. Now, this strange light, this memory written in photons, seemed to hint at something deeper, that the early universe might have remembered its own previous forms. Perhaps the Big Bang wasn't the beginning. Perhaps it was the continuation of something far older, a memory reawakening. At a global conference, one astrophysicist stood before a packed audience and said, "If these galaxies truly predate our models, then we're not looking at the universe's childhood. We're looking at its recollection. The crowd fell silent. Because if the universe has memory, then history isn't linear. It's recursive. Time itself may fold, echo, repeat. And maybe that's why the galaxy seemed so impossibly advanced. Because it wasn't new. It was remembering how to be. Of course, many rejected the idea outright. The universe doesn't have consciousness, critics said. It doesn't remember. It evolves. But those same critics couldn't deny what the data showed. Patterns that shouldn't exist, complexity that shouldn't appear, coherence that defied chaos. The more they tried to explain it, the more it slipped away, like a dream fading at dawn. And yet, that dream was real. It was written in the light. Dr. Elian Torres, the same scientist who'd whispered, "The universe doesn't crash, we do," wrote a paper that became infamous overnight. Its title, "The Memory of the Cosmos." In it, she argued that perhaps the universe doesn't begin and end at all. Perhaps it oscillates, not physically, but informationally. Each new universe inherits the lessons of the previous one, encoded in the subtle mathematics of reality itself. She wrote, "Galaxies like these are not mistakes. They are recollections. The cosmos is remembering its past in the only way it can. Through light." It was poetic. It was radical. And for many, it was the most beautiful idea they'd ever heard. Because it meant that nothing, not even existence, is ever truly lost. Every particle, every star, every thought we have might one day become part of the next universe's memory, carried forward like stardust in a cosmic chain of remembrance. Maybe that's why we look to the stars. Because somewhere deep within us, that same memory stirs. We are the universe remembering itself. And as that ancient light from the impossible galaxy continued to reach us, photons born billions of years before the first human dream, it felt less like discovery and more like reunion. A reminder that the past and the present aren't separate. They're reflections across time, across galaxies, across the infinite memory of the cosmos. For centuries, humanity believed time was a straight line, an unbroken arrow flying from the past through the present into the future. But the deeper we look into the universe, the more that arrow begins to twist. The discovery of the impossible galaxy cracked something in that old understanding. It wasn't just a challenge to astrophysics. It was an invitation to rethink time itself. Because if this galaxy formed before it should have, maybe before and after, no longer mean what we think they do. It's easy to imagine the universe as a vast, expanding balloon, galaxies moving apart as space stretches. But what if that expansion doesn't happen evenly? What if time, the hidden dimension that binds all of this together, is not smooth, but fractured? Like glass struck by an invisible hammer, perhaps time splintered during the Big Bang, creating overlapping regions where moments flow at different speeds, where evolution can skip ahead or lag behind. That would mean this galaxy didn't form too early. It simply formed in a region where time moved differently, a place where the cosmic clock ticked faster. Some theorists had toyed with this idea before, calling it temporal anisotropy, the possibility that time itself could have directionality, density, even texture. But until the Webb telescope, it was just math on a chalkboard. Now, for the first time, the data whispered that maybe the math was right. In one of the models presented by Dr. Al-Rashid, the universe wasn't a single synchronized expansion. It was a mosaic of time fields, regions where quantum fluctuations set their own rhythm in the early chaos after the Big Bang. If true, it could explain everything. Why some galaxies matured too quickly, why others lagged, why the cosmic web looks more like a living organism than a uniform pattern. The universe, it seemed, didn't unfold all at once. It bloomed. The idea divided the scientific community like a fault line. Traditionalists argued it was absurd. Time doesn't fracture, one critic wrote. It's a continuum. Einstein proved that. But others reminded them that Einstein had also said, "The distinction between past, present, and future is only a stubbornly persistent illusion." Maybe the illusion was finally cracking. To visualize it, imagine a map of the universe not drawn in space, but in time. Each point isn't a galaxy, but a moment, expanding, bending, merging with others. Now imagine that some of those moments are thicker, denser, faster, filled with energy. Others are thinner, stretched, slower, almost frozen. Where these time densities intersect, the universe becomes uneven, not broken, but dynamic. In one of those intersections, perhaps, the impossible galaxy was born, not ahead of schedule, but in a different rhythm altogether. A galaxy born from a faster heartbeat of the cosmos. There was poetry in the theory. It meant that time, like music, wasn't a single tempo. It was harmony and dissonance, rhythm and rest. And the galaxies, the impossible ones, were simply the first notes of a faster verse in the cosmic song. Of course, proving it would take more than poetry. New missions were drafted, ideas for space observatories capable of detecting temporal distortion signatures in the cosmic microwave background. If time really fractured in the beginning, those scars should still exist. Subtle patterns hidden in the oldest light. And so, once again, humanity looked backward to move forward. The deeper we looked into the past, the more the future began to change. For some scientists, the theory of fractured time was exhilarating. For others, it was terrifying, because it implied that the universe was not one story unfolding in perfect order, but a collection of overlapping narratives, each experiencing reality differently. One physicist asked quietly, "If time can fracture in the cosmos, could it fracture here too? Could two realities overlap? Two histories coexist?" No one answered. No one could. Late one night, a graduate student studying the data wrote a simple line in her research notes. Maybe the universe isn't expanding. Maybe it's remembering itself through time. And there it was again, that idea returning like an echo. Maybe time isn't just motion forward. Maybe it's reflection, the universe watching its own story unfold again and again through different lenses of speed and sequence. Maybe we are part of one of those reflections. The fractured map of time isn't something to fear. It's a sign that the universe is more alive, more dynamic, more beautifully imperfect than any equation could ever capture. And if time truly has texture, if some moments move faster, some slower, some even in loops, then maybe the impossible galaxy isn't impossible at all. Maybe it's simply older in a world where age doesn't mean what it used to. A reminder that in the great symphony of existence, even time itself must sometimes bend to the rhythm of creation. And somewhere beyond our reach, that rhythm still plays, a cosmic melody echoing through fractured time, calling us to listen closer. There are moments when silence becomes the loudest sound in the universe. Not because nothing is happening, but because everything is. When astronomers studied the light from the impossible galaxy, they also began to notice something even stranger. Faint patterns, not of brightness, but of vibration. Microscopic fluctuations in the frequency of light, oscillations too structured to be random noise. It was as if the light itself was resonating. The cosmos, it seemed, wasn't just glowing. It was singing. In the early universe, sound didn't travel the way it does here on Earth. There was no air, no molecules to carry waves, only plasma, a sea of charged particles humming with energy. But in that plasma, waves of compression and expansion, the very first sounds, rippled through the newborn cosmos. Scientists call them baryon acoustic oscillations. But maybe the heartbeat of creation would be a better name. Because those vibrations, frozen into the structure of space itself, became the scaffolding of everything that followed, the rhythm that galaxies, stars, and worlds would one day dance to. And now, 13 billion years later, we were hearing the echo of that rhythm again, in the light of a galaxy that shouldn't exist. The first time they plotted the frequency data, it looked like interference, a mistake. Then came the second observation, the same pattern, then a third, and finally, the undeniable realization. These ripples were real. It was as if the light carried a song, a faint, repeating cadence that spoke of motion, energy, and structure. Dr. Hannah al-Rashid called it the music of the first dawn. To understand it, physicists began converting the light fluctuations into sound waves, translating cosmic data into audible frequencies. What they heard stunned them. A slow, rising pulse, a deep, resonant hum, not chaos, but harmony. It wasn't a melody, not in the human sense, but it felt alive, like a voice from before time, whispering through physics. They realized then, the universe didn't just begin with light. It began with vibration. This discovery reawakened an ancient truth, one known to philosophers and mystics long before telescopes existed. That reality, at its core, might not be made of matter or energy, but of frequency. In the beginning, there was not silence. There was resonance. Every atom, every particle, every galaxy is part of that ongoing vibration, the eternal sound of being. And this galaxy, this impossible relic, was simply a note played louder, longer, echoing across the fabric of space. Somewhere between science and poetry, a new understanding began to take shape. Perhaps the laws of physics are not rules written once, but harmonies sustained over time. Gravity, light, motion, all different expressions of the same song. And the impossible galaxy? Maybe it was a place where the harmony peaked, where the frequencies aligned just right to accelerate creation itself. A cosmic crescendo. At one observatory, a group of researchers decided to map the light patterns of multiple early galaxies onto an audio spectrum, layering them, listening for coincidences. The result was haunting. A rising chorus, low pulsing tones that interlocked like chords, high frequencies that shimmered and vanished like sparks. When they played it back, the room fell silent. It wasn't random. It wasn't noise. It felt deliberate, not as design, but as coherence, as if the universe itself remembered its opening act. There's a strange comfort in that idea, that creation has rhythm, that the chaos of the Big Bang wasn't chaos at all, but music, dissonant, yes, but purposeful. Maybe every galaxy, every star, every heartbeat since has been part of that same universal score, vibrating at its own pitch, yet belonging to the same cosmic orchestra. And maybe, just maybe, the impossible galaxy wasn't the first mistake in our understanding of the universe. Maybe it was the first verse of a song we were never meant to forget. Dr. Torres said in an interview, "When I look at the light from that galaxy, I don't see an object. I hear something. It's like the universe is reminding us how it began." The journalist asked, "And how did it begin?" She smiled. with a sound. Because before there were stars, before there was space, before there was even time, there was vibration, the sound of creation. And now, after 13 billion years, we are finally learning to listen again. For weeks after the discovery, the world buzzed with theories. Every scientist, philosopher, and dreamer had an opinion. But none were as provocative as this one. What if the galaxy we found wasn't from our universe at all? What if it was a reflection, a mirror, shining back from the other side of reality? It sounds like science fiction, but the universe has a strange sense of irony. Every time we think we've reached the edge of the possible, it quietly reveals another horizon. In the equations of quantum mechanics and relativity, there is room for symmetry, not just in space, but in time. For every particle, there exists an antiparticle. For every direction, an inverse. For every expansion, perhaps a contraction. So what if the Big Bang wasn't a singular event? What if it was a meeting point where two universes were born back to back, one expanding forward in time, the other expanding backward? In this mirror cosmos, time would run in the opposite direction. Entropy would decrease instead of increase. Stars would collapse into youth instead of age. From our perspective, it would look ancient, impossibly old, impossibly formed, exactly like the galaxy we found. A team at the European Space Agency began exploring the math. They called it the reflective universe model. It suggested that what we see as early light might actually be light from the other side. Photons slipping through the thin boundary where both universes touch. To us, that light would appear red-shifted beyond belief, ancient, far, mysterious. But to observers in the mirror universe, it would be brand new. Our beginning might be their end. One astrophysicist compared it to a mirror with cracks. When you look into it, you see both reflection and distortion, a dual reality, intertwined but incomplete. If our universe and its twin truly exist side by side, they might occasionally bleed into each other through gravitational or quantum overlap. Not enough to merge, just enough to whisper. And maybe the impossible galaxy was one of those whispers, a glimpse through the crack. Philosophers loved the idea. It gave poetic meaning to existence, that creation wasn't a lone explosion, but a dialogue. That the cosmos itself was a conversation between opposites. Chaos and order, life and entropy, time and reflection. Science fiction writers, too, were quick to follow. They imagined explorers crossing that cosmic boundary, stepping from our timeline into its reversed twin, watching stars undie, galaxies unform, history itself rewinding into light. But for the scientists, the question was simpler and heavier. If such a universe exists, can we prove it? The challenge lay in measurement. A mirror universe wouldn't obey our concept of causality. Light from that side might arrive before its source exists in ours. To detect it would be to witness something from the future, though in truth, it's just another direction in time. And yet, there were clues. Deep in the cosmic microwave background, the afterglow of the Big Bang, researchers noticed faint asymmetries. Tiny distortions, small but consistent, as if something was tugging on space-time from beyond. It wasn't proof, but it was enough to keep the idea alive. If it's true, then every photon we see from the early cosmos might have a twin, moving the other way. Every action here might cast an echo there. In that sense, we might all be reflections, not copies, but harmonies across universes. The impossible galaxy, then, isn't impossible. It's a mirror, showing us what creation looks like from the other side. Dr. Hannah al-Rashid once said during an interview, We spend our lives looking out into the universe, but maybe the universe has been looking back all along. The host laughed. You mean like a mirror? She smiled. Exactly like a mirror, except this one remembers you. The mirror universe isn't just a theory. It's a metaphor for balance, for reflection, for the eternal duality of everything that exists. Light and shadow, birth and decay, understanding and mystery. Perhaps that's why this galaxy feels so hauntingly familiar. Because when we look at it, across 13 billion years of space and time, maybe we're not just seeing something distant. Maybe, for the briefest moment, we're seeing ourselves. And somewhere, in that other cosmos, if it exists, perhaps they've found their own impossible galaxy and are asking the same question we are now. What if we're the reflection? It's easy to think of galaxies as distant islands, vast, isolated, timeless. But the truth is far stranger. The universe breathes, not in the way lungs do, but through expansion and contraction, through rhythm and resonance. Every pulse of creation sends ripples across the cosmos, invisible yet powerful, shaping everything, from the dance of atoms to the swirl of galaxies. And perhaps, somewhere within that breath, lies the key to understanding the impossible. For decades, scientists assumed the universe was expanding forever. That space itself was stretching endlessly outward. But recent data from distant supernovae and the cosmic microwave background began suggesting something more dynamic. The rate of expansion isn't constant. It changes, sometimes accelerating, sometimes slowing, like an organism adjusting its heartbeat. And suddenly, the metaphor of cosmic breath didn't sound poetic anymore. It sounded accurate. When astronomers modeled this rhythm, the subtle oscillation of expansion, they realized it could explain anomalies like the impossible galaxy. In certain breaths of the universe, expansion slows, allowing matter to clump faster, stars to ignite sooner, and galaxies to form earlier. Then the next breath accelerates again, scattering the pieces outward. The cosmos, in other words, doesn't just grow. It inhales and exhales. Dr. Elian Torres described it beautifully in her lecture. The universe is alive in ways we don't yet understand. It's not a machine. It's a heartbeat that never stops. And maybe, she said, this galaxy was born in one of those breaths. A pause in the expansion, a stillness in which creation could briefly accelerate. Like a lung filling before the next exhale. That realization changed everything. Because if the universe breathes, then it might also remember its rhythm. A cosmic pulse encoded in gravity, energy, and time. We began to wonder, how many breaths has the universe taken since the beginning? Could each one mark an era, a chapter in the story of existence? Maybe this galaxy, impossibly ancient and beautiful, was a fossil from the universe's first breath. Across the world, observatories and satellites began to listen for that rhythm. The subtle gravitational oscillations that could confirm the cosmic pulse. One instrument, deep underground in Italy, picked up something strange. Faint gravitational waves, recurring at intervals far too regular to be random. They were weak, almost ghostly, but real. The signal repeated every 2.6 billion years. Too slow for a human lifetime, but perfect for a universe. At first, some dismissed it as noise, but when another observatory, this time in Japan, detected a nearly identical pattern, silence fell over the scientific community. The data matched. The rhythm was real. The universe was breathing. That revelation sent a shiver through humanity's understanding of everything. Because if the cosmos breathes, then it isn't just a passive backdrop to existence. It's a living system, an engine that inhales energy and exhales matter, not mechanical, but almost organic. It made people wonder whether life, in all its fragile, improbable forms, wasn't an accident at all. Maybe life is what happens when the universe exhales. Imagine that. Every atom in your body, every molecule of air, every spark in your neurons, part of a grand cosmic respiration. You inhale, and so does the universe. You exhale, and the stars echo it back. Maybe the rhythm that guides galaxies and the rhythm that guides our hearts are not different things, but the same pulse, echoed across scales we can barely comprehend. The breath between stars. When asked what this meant for science, Dr. Torres smiled and said, "It means we're not separate from the universe. We are the universe, the part that knows how to breathe." And maybe that's why we're drawn to the stars, not just to explore them, but to find the rest of our own heartbeat in the silence between them. Because that's what the impossible galaxy is teaching us. It's not just a mystery to solve. It's a reminder that even across 13 billion years, through the darkness and the light, the universe is still breathing. And so are we. It began with a signal, faint, inconsistent, and impossible. A repeating pattern in the data from deep space telescopes, buried within the noise of cosmic radiation. At first, no one paid attention. The universe is full of background static, whispers from dying stars, remnants of long-vanished quasars. But this signal was different. It didn't behave like an echo from the past. It looked like something coming from ahead. When the analysis came in, the shock was immediate. The wavelength of the signal suggested it originated from beyond the observable universe, from a point that, according to every model, doesn't exist yet. One astronomer murmured, half joking, half terrified, "We're picking up ghosts from the future." And somehow, that description stuck. The ghosts of tomorrow became the next mystery. Faint energy signatures that shouldn't exist, but did. They appeared briefly, then vanished, always returning at the same intervals, like a heartbeat beneath the cosmic noise. The frequencies didn't match any known natural phenomenon. They were too coherent, too rhythmic. For a while, some believed it was interference, signals bouncing off satellites or debris. But the timing was too precise, the pattern too persistent. And the direction? Always from the same place. The region of sky where the impossible galaxy had first been found. That connection couldn't be ignored. What if the galaxy wasn't just old? What if it was out of time? Perhaps it existed in a layer of the universe where time flows differently, allowing signals to leak across temporal boundaries. To us, those transmissions would seem like echoes from the future, because, in a sense, they are. The universe, after all, doesn't distinguish between forward and backward. Only we do. The more scientists studied it, the stranger it became. When the signal was slowed down and converted into audio frequencies, it produced an eerie, undulating tone. Not random, not mechanical. It had structure, like a language waiting to be decoded. Quantum theorists proposed an idea both thrilling and terrifying. Perhaps time is not a line, but a loop, constantly folding in on itself, connecting beginnings to endings, cause to effect. If that's true, then the ghosts of tomorrow aren't messages from the future. They're feedback, the universe talking to itself. Every galaxy, every particle, every thought might be part of that conversation. A constant exchange between what has been and what will be. And this impossible galaxy. Maybe it's a node, a point where that feedback becomes visible. a bridge between what was, what is, and what could be. Dr. Hannah al-Rashid once described it this way: "The universe isn't linear. It's recursive. It loops on itself like a thought. Sometimes, when those loops overlap, we see reflections, echoes that haven't happened yet." Her statement caused outrage among skeptics, fascination among dreamers, and sleepless nights among theorists. Because if that's true, then maybe the future isn't waiting for us. Maybe it's already here, woven into the light of the past. In one particularly haunting experiment, researchers tried aligning the ghost signals with known gravitational wave events. To their astonishment, some of the pulses appeared to precede those cosmic events, by days, sometimes weeks. In other words, the signals arrived before the galaxies collided, before the supernova exploded, before time, as we know it, had the chance to act. That discovery broke the internet, and then the scientific community. Some claimed it was evidence of a multiverse, where causality itself is blurred. Others said it proved that information can travel backward through space-time. And a few whispered something even more profound: that maybe the universe knows what's coming, because it's already happened. Dr. Elian Torres, ever the philosopher, put it best in her closing address at the 2036 Astrophysics Summit. "The ghosts of tomorrow are not warnings or miracles. They are continuity. The cosmos doesn't end or begin. It loops. What we call the future is just another layer of the present, unfolding in rhythm with the past." The audience fell silent, because deep down, they all knew she was right. The impossible galaxy wasn't defying the laws of the universe. It was revealing them. It was showing us that time is not a wall. It's a mirror. And sometimes, when we look deep enough into the reflection looks back. That's what the ghosts of tomorrow are. The universe remembering its next breath, its next thought, its next heartbeat. And through that ancient galaxy, through that faint light that shouldn't exist, we are finally starting to hear it whisper, not from behind us, but from ahead. It began as a dare, a quiet challenge whispered among physicists after midnight during a symposium in Geneva. "Try to build an equation," one of them said, "that makes this galaxy make sense." For months they tried. For months they failed. Every known model of cosmic evolution, every simulation, every particle equation, all of it collapsed when confronted with this ancient light. The numbers refused to agree. The constants didn't behave. It was as if the universe itself was saying, "Your math ends here." Then came Dr. Ishan Rao, a soft-spoken theoretical physicist from Bangalore who was more poet than mathematician. He didn't try to fix the equations. He tried to listen to them. He believed that math, like music, could reveal harmony, not just correctness. He asked, what if the laws of the early universe weren't the same as ours? What if symmetry wasn't broken yet? And that's when something clicked. He rewrote Einstein's field equations, not as rigid relationships, but as fluid transformations, patterns that could shift with the density and temperature of space-time itself. When he ran the simulation, it worked. It wasn't supposed to. The model produced galaxies, large, luminous, structured, forming hundreds of millions of years earlier than previously possible. The impossible galaxy appeared, not as an anomaly, but as a natural outcome. The universe, in his model, evolved faster because its own rules were still solidifying, like wet paint hardening after a cosmic brushstroke. Gravity, light, even time, all were still negotiating their forms. And in that chaos, creation could move at impossible speeds. Dr. Rao called it the fluid cosmos hypothesis. It proposed that during the universe's first billion years, physics was flexible. Constants were not yet constant. Light could bend differently. Gravity could fluctuate. Time itself could stretch and fold like silk. In such a universe, the impossible becomes inevitable. The reaction was electric. Half the scientific world called him a genius. The other half called him a dreamer. But even his critics couldn't deny one thing. His math worked. For the first time, someone had built an equation that fit the data. When they fed the Webb telescope's readings of the impossible galaxy into his model, it aligned perfectly: luminosity, density, even metallicity. The universe suddenly made sense again, just not in the way anyone expected. A journalist asked him, "Do you really believe the laws of physics can change?" Dr. Rao smiled softly. "I don't think they change. I think they learn." That single sentence spread across the world, quoted in articles, printed on posters, whispered in classrooms. It reframed everything. Because if the laws of physics can learn, then the universe isn't static. It's alive, evolving, adapting, perfecting itself across time. And that would mean we are not the observers of creation. We are part of its education. His hypothesis ignited a renaissance of scientific philosophy. It inspired debates not about what the universe is, but how it becomes. It even gave rise to a new term in cosmology: evolutive physics, the idea that reality itself is capable of growth. Maybe, Rao argued, that's why we exist, not as accidents, but as instruments, through which the universe explores its own potential. Every discovery, every equation, every mistake, all of it, part of a grand feedback loop of learning. When asked if he believed in God, Rao laughed gently. "I believe the universe is teaching itself to be divine." The implications of his model were staggering. It suggested that the cosmos could still be changing its rules, right now, even as we speak. That constants like the speed of light or the pull of gravity might shift ever so slightly over eons, shaping new forms of matter, energy, and consciousness. If that's true, then every impossible discovery isn't a contradiction. It's a reminder that we're watching reality learn how to exist. Late one night, a colleague visited Dr. Rao's lab and found him staring at his screen, the galaxy's simulation spinning slowly before him, glowing like a living thing. She asked, "What do you see when you look at it?" He smiled. "I see a mind, vast, patient, and curious, the universe trying to understand itself." The next morning, his paper was published. Within hours, it broke every record in academic history. Within weeks, it reached beyond science, into art, literature, religion. Because for the first time, someone had written the math for wonder, and for the first time, it worked. So maybe the impossible galaxy isn't impossible after all. Maybe it's proof that the cosmos is still learning how to sing, and we are its newest verse. There comes a moment in every civilization story when it dares to look so far, so deep, that it accidentally catches its own reflection in the eyes of creation. For us, that moment came when the James Webb Space Telescope turned its gaze toward the ancient darkness and saw something looking back. The impossible galaxy was no longer alone. Dozens of others began appearing in the same region of sky, faint, luminous, perfectly structured, all far older than they should be. It wasn't one anomaly anymore. It was a pattern. And patterns, in the language of the universe, mean purpose. The discovery sent shockwaves through every discipline: astrophysics, theology, even philosophy. One Vatican astronomer was quoted saying, "Perhaps these are not just galaxies, but memories of creation itself." the fingerprints of a divine mind learning how to build. Others disagreed. Divinity, said Dr. Torres in a now famous interview, is just a word we use when science outgrows our vocabulary. But even she admitted that something about those galaxies felt intentional. They were aligned. Their formation followed a rhythm, almost like constellations, not drawn by us, but drawn for us. When plotted together, the positions of the galaxies formed a spiral, not a random cluster, but a vast, elegant geometry spanning billions of light years. The same mathematical ratio that defines seashells, hurricanes, and DNA. The golden ratio. It was as if the architecture of life and the architecture of the cosmos were two verses of the same song. Dr. Ishan Rao, whose fluid cosmos hypothesis had already turned science on its head, stared at the data for hours before saying a single word. Its self-similarity. The universe is looking at itself. In that moment, everyone in the room understood. This wasn't chaos. It was symmetry, recursive, reflective, alive. The universe was fractal, and if Rao was right, it wasn't just physical, it was conscious. The idea spread like wildfire. The cosmos might not just contain awareness, it might be awareness. Every galaxy a neuron, every light pulse a thought, every pattern a memory forming within an infinite mind. We weren't observing the universe, we were watching it think. Theologians, mystics, and physicists suddenly found themselves speaking the same language, the language of awe. A quantum biologist wrote, "If the structure of galaxies mirrors the structure of neural networks, then perhaps consciousness is not born in the brain. Perhaps it is born in geometry." And that thought changed everything. It became impossible to ignore the parallels. The spiral of galaxies, the swirl of hurricanes, the shell of a nautilus, the coil of DNA, all following the same proportion, the same curvature, the same silent rule. It was everywhere. One journalist called it the signature of existence. But what was it signing? Dr. Rao and Dr. Torres co-authored a paper that dared to ask the unaskable question. If consciousness emerges from complexity, and the universe is the most complex system imaginable, then is the universe aware of itself? The answer, of course, was unknowable. But the evidence was there. Symmetry upon symmetry, fractal upon fractal, harmony upon harmony. The deeper we looked, the more it seemed like everything was connected. Not metaphorically, but mathematically. The same equations that govern galaxy formation also appeared in biological growth, in the patterns of waves, even in human heart rhythms. It was as though the universe had one design principle, repeating itself endlessly, from the infinite to the intimate. The media, as always, simplified it. Headlines blared, "Astronomers discover the face of God." "The universe is alive, scientists confirm." The scientists, of course, said no such thing. But privately, many admitted that, standing before the telescope data, they had felt something sacred, not religion, recognition. Because if the universe truly mirrors itself, if the pattern of stars and the pattern of synapses are one and the same, then we are not separate from creation. We are its reflection. Late one night, while analyzing the geometric models, Dr. Torres whispered to Rao, "What if consciousness isn't the exception, but the rule?" He replied, almost absently, "Then awareness isn't ours. It's the universe remembering itself through us." Neither of them spoke after that. They didn't need to. Because in that moment, surrounded by glowing simulations of galaxies and equations of light, they understood something quietly revolutionary. We are not observers in the cosmos. We are instruments of its perception. The eyes of God are not distant or divine. They are every telescope, every retina, every atom capable of wonder. The universe is looking at itself through us. And in the light of that impossible galaxy, ancient, impossible, perfect, it finally saw what it had been searching for all along, itself. And somewhere, in the silence between those galaxies, in the endless spiral of geometry and thought, perhaps it smiled. There is a moment before every revelation, a breath between ignorance and understanding, when the universe seems to hold its breath with you. For centuries, humanity had stared into the stars, convinced it was looking outward. But in truth, we had been looking inward all along. The impossible galaxy, once a mystery, had become a mirror. And through it, the universe finally unveiled its deepest truth. Not a secret of physics, not a code to break, but a realization. We were never separate from it. It began quietly. A final analysis, a final rendering, a final piece of data arriving from the Webb telescope before its systems shut down for recalibration. The light from that ancient galaxy, filtered, cleaned, and decoded, revealed an unexpected pattern, a spectral distribution identical to that of the Milky Way. Not similar, identical. It was as if we were looking at our own reflection 13 billion years delayed. No one wanted to believe it at first. It had to be coincidence, interference, human error. But the deeper the analysis went, the clearer it became. The galaxy's composition, its chemical fingerprint, its elemental ratios, all mirrored ours. Oxygen, hydrogen, carbon, nitrogen, in precisely the same proportions. Even its star clusters matched the Milky Way's layout on a macro scale. It wasn't just a reflection, it was us. Dr. Rao said it first, barely above a whisper. We've been seeing our own light, bent back across time. The universe, vast and curved, had folded the oldest light around itself, sending us an image of who we were destined to become. The impossible galaxy wasn't ancient after all. It was future light, photons that had traveled the long road of cosmic curvature to arrive here, from what would one day be our own descendants' sky. We had been staring at tomorrow. That realization broke every paradigm, every boundary, every human definition of now and then. Time, it seemed, had closed the loop. The universe had shown us the final truth. It is both origin and outcome, creation and reflection, dream and dreamer. And in that symmetry, consciousness wasn't an accident, it was inevitable. The universe had evolved eyes so that it could finally see itself. Every scientist reacted differently. Some cried, some prayed, some simply sat in silence, overwhelmed by the enormity of what had been revealed. Humanity's greatest question, are we alone, had been replaced by something deeper. Are we the universe remembering itself? And the answer, it seemed, was yes. When Dr. Torres addressed the United Nations later that year, she didn't bring charts or equations. She brought an image, the light curve of that galaxy, the echo of our own reflection. And she said, "We used to believe we were small. We used to believe we were latecomers to a vast, indifferent cosmos. But maybe, just maybe, we were the point all along. The moment when the universe finally became aware of what it had made." Her words were broadcast to every corner of Earth. For once, no one argued, because in that moment, everyone, from scientists to school children, felt the same quiet truth. We were home. Religions adapted. Philosophies evolved. Science didn't lose meaning. It gained soul. The cosmos wasn't a machine anymore. It was an organism. And we, its consciousness, were the neurons firing across the darkness. Years later, when humanity began building the first interstellar vessels. They painted a single phrase on their hulls, words taken from Dr. Rao's final notebook before he died. "We are the echo and the origin." It became the creed of a new age, one where exploration wasn't conquest, but communion. One where looking into the sky meant meeting the eyes of our own reflection. And perhaps somewhere across that infinite distance, in the faint shimmer of the impossible galaxy, our descendants, or our precursors, are looking back, asking the same questions, feeling the same wonder. The circle is complete. Not the end, not the beginning. Just the continuation of a single, endless thought. The universe thinking itself awake. We are not lost in the cosmos. We are the cosmos, remembering how to dream. And the dream goes on.